Cool. It's a talk about doing things wrong, so this is a good start. Thank you for coming, everyone. Yeah, I am glad that you are here to see me make some mistakes in front of you, and we can all count it as a learning experience at the end of the night. So just remember that if you spot any typos or other mistakes, it's all intentional. I've planned it and rehearsed it all. It's like a Tommy Cooper sketch. And so you don't need to highlight anything I did wrong at the end. Just say nice things, okay? Who am I? My name's Mike. I'm CTO for a prop tech startup. I'm a northerner, so sorry if you struggle understanding me at any point this evening. And I'm a skydiver. Skydiving is generally more fun and only slightly more dangerous than programming. So come talk to me afterwards if you want to learn anything about that. We do have a joined in link for this talk. I don't know if Craig knows we had a joined in link for this talk, but I put a link on joined in because I like getting feedback because genuinely I love doing this. And it's really great to hear whether people liked it. And if they didn't like it, it's really great to hear why, because then it helps me do better for all of you next time I come, if you invite me back. And you can follow me there on Twitter at M1KE. And we're going to start this talk with some audience participation. So that traditional London talk to strangers mentality needs to sort of go away right now, and you need to all participate. So how many years have you been a developer? Let's do some hands up rather than you all just shouting numbers at me. Put your hands up if you've been a developer for at least 1 year. Okay, keep them up if 2 years. Keep them up for 5 years. Keep them up for 10 years. Keep them up for 20 years. Okay. I don't know any numbers over 20, so we're just going to stop there. So we've got some experienced people here, and we've got some less experienced people here. But I'm sure all of you know by now that if you're doing this as a hobby or as a career, you will make mistakes. So maybe you've realized that. Maybe you've realized it in quite a tough way. Maybe you've made a mistake that has cost someone a lot of money. Maybe it's cost you a lot of money, maybe a job. Hopefully no one has caused an aircraft to crash or anything similar. But if you have, then try not to take too much from this. But I think I'd say to that, don't lose the chance to make mistakes and let them count as a learning experience. Because you will make mistakes. It's inevitable. It's a part of life. And in fact, it's what you do afterwards that counts. So the reason I'm stood up here is because I want to share some of that with you today. I found this quote recently. It says, you truly become an adult when you finally realize nobody knows what they're doing. This was posted in response to an incident last year, January 2018, I think it was, when an early warning missile alert system went off in Hawaii, telling residents that an inbound cruise missile, or ICBM or something, to Hawaii, everyone assumed it was probably North Korea nuking them, and just kind of lost it for 38 minutes until they kind of rescinded this warning. Now, it turns out this warning actually wasn't because of a software fault, which everyone was surprised about afterwards, I know. It was the fault of an employee who just didn't really get the message properly, that this drill that everyone was shouting the word drill around him was a drill. We're not going to dwell on that too much, but obviously mistakes can be pretty big sometimes. But we still want to give ourselves a chance to make mistakes in safer spaces. Make mistakes when you are not controlling the early warning missile system alert for the island of Hawaii, for example. And so sharing them with each other is my thing here. So my goal here isn't just to talk to you about a lot of mistakes I've made and what you can do about them. It's for you to leave talking about mistakes you've made and what each other can learn about them, so people can overall make less mistakes. And if you think your mistakes are bad, just imagine how your computer feels when you make those mistakes. And so these are a list of mistakes made over my career. And as a result of that, and to help my future employability chances, I'm going to reintroduce myself. Hi, my name's Dave. You don't know me, but I did these things. So let's get started. Number one, I allowed users to edit one another's profiles. I call this the world's dumbest zero-day. A zero-day bug is a security term for a bug which was present from the very first time some software was deployed, but just nobody's found it yet. So it wasn't a regression, it wasn't introduced later, it's always been there, and no one knew about it. So this was found 4 years into a specific project by an intern on that project. Let's look at some code, because that's what we all like doing at PHP meetups. We like looking at code. Here's some simple code. We check some information about a user. Is the user that we're trying to edit the logged in user? If so, we edit the user. This code has been dramatically simplified, so you don't have to learn about our weird routing or request handling. So I wouldn't normally suggest putting the global post variable straight into a function like this, but hey, you do you. And it turned out that with a small change to the request, any user who was signed in could edit any other user. Maybe you've spotted it already. That's a single equals sign there, which in PHP and most of the languages is known as an assignment operator. An assignment operator makes one variable equal to the value passed to it. Returning the truthy value of an assignment simply is the same as returning truthy value of the thing you're assigning to. So this equals this will return true as long as the thing you're assigning to is not false. So at this point, any user can edit any other user's profile. And when someone pointed that out to me, a newcomer to our team said, I think we've got an issue. I said, no, it's been in production for 4 years. 4 years. And then he showed me, and I was sort of a little bit, oh, that's not good at all. Now, luckily this site was fairly low traffic. As far as we could tell, nobody had exploited it. And so we deployed a quick fix, right? Same code, extra equals sign, right? That's a quick fix, okay? The bug's fixed, the wolves are away from the door. But could we actually have done something from the start of this procedure, before this code was even written, to put ourselves in a place not to make this mistake in the first place? And obviously the answer is yes, otherwise I wouldn't be putting it in a talk. Bigger equality is harder to miss. This is a very simple thing. This is not some general complicated procedure. This is just saying that that is hardest to spot, that is slightly easier, and that is really obvious. There is a difference between these two. Double equals is a simple comparison, a weak comparison in PHP. It will do PHP's famous type juggling. If you think you know type juggling, there is a quiz that you can do at some conferences which will show you don't know what type juggling is. And yeah, just look out for that if you ever see it on a conference schedule. It's fantastic. But the strict equality is also good for other reasons. It prevents other fun PHP typing bugs, like a string beginning with a number being equal to that number. But in this case, I simply say using that equals and some spaces makes this way more obvious than this. Harder to miss, just code that is obvious from looking at it. Nothing else about the language, nothing simple. Nothing complex, just simple readability. Well, what else can save us? Okay, let's actually look at some more language features. Well, we can use flipping the comparison. A equals something. We'll assign A to the return value of something. Okay, so if you do that, you'll get a working statement. If you do something equals A, you'll get a PHP level error, because you can't assign the return value of a function to something. And there are various formats of this that will work for you. For example, if you have a const, stick your const at the start of your comparison, because if you miss out an equal sign there, again, you can't assign a const to something else in the middle of a program. Derek's looking at me. He probably knows some weird way in the internals that you can do this, but I'm sure it's safe for most people. The other thing you can do is a better method structure. So rather than saying, if I can do this thing, do the thing, else throw an exception, why not check for our falsy value first? And this actually allows us to check for multiple false values. You'll notice when you're writing most procedures that you tend to check for one or more things to mean the procedure can't continue. Exception cases, or return false, or just return. And then you do the thing you're trying to do. So in this case, throw out access exception early. You do two things. Firstly, you prevent this problem. Not equals is pretty hard to mess up and assign something to. That not is fairly obvious in your code. It's fairly hard to miss out. And if you miss the not sign, your code will literally do the wrong thing. It will throw the error for any user trying to do this. And it's also more readable. People can look down a list of the user shouldn't be able to do this, 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 or this, and then they can do this. So your code becomes more readable if you throw exceptions or return early in it. And this doesn't just apply to security conditions. This is general good coding practice. To return early or throw exceptions early in your code, rather than big nested blocks of if and else if and everything else in between. What about tests? Some people are thinking, well, why didn't the test catch this? Well, the tests checked the happy path, the path we expected to happen. Can a user edit their profile? Yes, they can. No one thought to change that user ID to something that the user shouldn't have been able to do. In security, it's better for stuff to fail to work for the average user than to have a bug that the average user won't notice, but your evil hackery type will find. Right? If your users can't edit their profile, they will tell you. Mr. Nasty Hacker 57, gmail.com, is not going to tell you you have a bug. He's going to try and either sell it back to you or sell it to someone else. Working should be defined as secure. Okay? If your application is not secure, you're not serving your users. And so doing everything you can to make sure an application is secure is pretty important. Speaking of security, I let the database password get published to GitHub. You've probably heard about credentials on GitHub in the past. Someone's videoing or taking photos of all this, so I'm definitely getting fired. Let's find out how it happens. It starts out really simple. You hire someone new. And you say, do this thing with our data. We want some analysis done. It'll give you a chance to explore the database and work out how we do things and produce a little bit of value for us. Brilliant. And then, yeah, our credentials are in this file. Just check out the project from our private repository. The credentials are in the file. And then Saturday the phone rings and you sort of hear, oh, they just said they wanted to show what they've been doing at work. Turns out the developer had published their little script and set up, including credentials, to their public GitHub page, panicked and called the boss, and I got the phone call ending up a little bit like this. What went wrong with this one? Well, probably obvious. We had a new staff member. Now, not saying that new people are always a danger, but people who don't know the way you work tend to copy the way you already work. We were committing our credentials to version control, which is a bad idea. And this developer simply committed credentials to their version control. And then there was a kind of mental gap between doing that and publishing it on a public GitHub page. But you can see how it can happen. You're setting a bad example to people who are incoming into your business. Yes, you can blame them for a stupid mistake. They thought they were going to get fired. We just was like, well, you've shown us a problem in our security, haven't you? So I guess we keep you. But what examples are you setting? What examples are you setting? Are you sort of saying, hey, follow all these great practices, ignore that code over there. That code just works, we don't touch it. So there's a big management side of it. But there's also a practical side. We can store secrets securely. Conventional way to do this are environment variables, config files that exist outside your version control, or API-based secret managers. I'm going to briefly introduce those concepts. This is an environment variable. It's a common feature of Unix and Windows, and probably a lot of other operating systems. You define a variable before you run something, so in this case, db user is root, and then you run PHP and then there's the script. And now, inside that script, you can say get env db user, and it echoes root. So now, something from outside your system, outside your script, outside the scope of your version control, maybe sitting on the server with good permissions on the file, can influence how your script runs. It's common to store these in a .env file. .env isn't a magical extension. Some services now treat it as a bit of one, but basically a .env file is a shell script that adds variables into your current running shell session. The nice thing is you can source these in your command line, so you can do source.env, and now anything you run has access to all these environment variables you've got set up. So API keys, database credentials, anything else that's kind of secure and important for just that one run. And they can be inherited. So if you're using a container environment, using Docker, Docker Compose, then you can inherit environment variables either from a file or again by passing them to Docker Compose. If anyone's using, hands up, anyone using Docker Compose? Yeah, so you've just got an environment variable key. You've probably seen it in your YAML files. They can also be loaded by web server configs, so Apache and Nginx and other hipster servers have ways to load environment variables into the server, so anything they run has those environment variables. And finally, there are custom .env loaders, such as symfony.env and various other PHP search on packages for .env files. You can have a dev version. So this dev version stores all the dev credentials, sandboxes to APIs and things like that, that sort of it's safe to put in your version control because they go to restricted resources. And so all your devs can have that without you having to find a way to share secrets between them, which inevitably leads to some sort of leakage anyway. And then have a secure version for production that's not in your version control system. And then things like the .env Symfony library allow you to load multiple versions of your files, so you can combine like a dev's local preferences with something on the server, or switch to a live key for a really weird debugging scenario or something. .env has a few cons. .env environment variables are inherited by child processes. So if you run something like exec this, your anything you run in exec has access to your environment variables. So if you're doing something where you're execing another script, that script now has all the credentials that your PHP file had access to. So be careful with that one, because again, if there's sensitive credentials in there and you run some sort of untrusted script on your box, that now has all your environment variables too. Why you're running untrusted scripts on your box through PHP, I don't know, but it's just another vector. And finally, you can use plain config files. So if you're going to use a PHP env loader, the fact it's an env file doesn't necessarily matter as much to you. It can still be handy for other circumstances, but just have some sort of config file which allows you to properly document the variables that you've got access to. Finally, there's API secret storage. I'm just going to talk about 2 services. There's probably a ton more. You can all shout them at me afterwards or tweet them at me. But the 2 that I am aware of and have used are HashiCorp's Vault, which basically is a server you maintain somewhere, run on your infrastructure, that has all your secrets, and you can configure loads of different access methods into Vault so that your services can get the credentials when they need them. And you can do things like saying, this server can get the database password, but only this server can get the API key to our payment gateway. And then AWS have a service called Secrets Manager. For anyone on AWS, Secrets Manager is a really easy sort of turnkey solution. Put some secrets in, define access to it with the existing role-based permission system that you use for everything else in AWS, and your servers have access. The only problem I found with Secrets Manager is it can get quite expensive if you're storing lots of individual secrets. So just be aware of that. But the flip side is if you run something like a Vault server, that's now a critical failure path of your entire application. If that goes down, your application loses its credential access, which is probably important to it. So what was our next problem? Well, we've had some fun ones so far. I mail bombed an entire mailing list. This is how you learn objects aren't just for separating your concerns. So we had a new emailing system. It was going to do some we had a marketing team doing sort of automatic stuff, manual stuff. We wanted to automate that to save them a load of time. Just pull out a load of emails, customer emails that are valid, generate an email to them, send it. Boom. Saved marketing time, money, profit, all that stuff. We ran it. Seems to be going okay. Then I got a message. They said they just received the same email 1,000 times with more users copied in. And like, what? You sign onto your server and you're hitting Control-C. What happened with this one? Here's some code. There's a bit more code. I've tried to sort of redact it enough, but it's to make it still look like a reasonable block of code. Anyone use PHP mailer? I wouldn't recommend it. This was a sort of PHP mailer script. We get a mailer, get some messages, we loop over them, set a subject, set some content, add a recipient, and send it. Boom. Anyone spotted it? Yep. So, naming things is quite important. Set generally means you change the value of something in an object. So set this, that value changes. Add generally means you're adding to an array. So each time we loop through this, we add a new recipient. So Mr. A.Arnold received a lot of emails from us with progressively more other angry users copied in. I think this is the bug that led to the most loss of customers for that company. Fortunately, this was before GDPR, a long time before GDPR. But maybe this is the reason why GDPR got introduced. Who knows? Yeah, there are only 2 hard problems in computer science: cache invalidation and naming things. Naming things is important, but also reading them is important. So we have a convention of set and add, and I completely ignored that convention when I wrote this. So again, quick fix. Let's get the system working. Safe send. Practice safe send. You send it and then you clear. And then you ban any use of the send function in code reviews. Or you add an internal or deprecated or something else .block to it, or you find some other way of preventing any programmer using it in future. Your system now works, and you're not sending out all these emails. Can we do better? I imagine we can. We write a custom system which doesn't allow us to make mistakes in the first place. We talked about this earlier with the new staff member. If you give people the tools to mess up royally, chances are they'll mess up royally. PHP as a language has some of those tools inherently inbuilt into it. So you kind of have to put a few walls around those in things like code reviews or PHP code sniffer or PHP mess detector or anything you want to use in that process. But there are ways you can write your own systems that make them also a bit more predictable. So we have an email service. The mailer is private. Nothing else can access it. We have a send function. It takes a message object, which is everything in the message except the email. We set to the email and name from this function, and then we send it. And so now, as long as this is where we send all our emails, we can't run afoul of anything. Okay? Now, for those who are aware of PHP and how it handles objects versus other variables, objects are passed by reference. If you pass message into this and then you give message to some other mailer somewhere else, it can still have the values you've put on it in this function. So this function is not isolating that change to message. That change gets propagated to wherever message is elsewhere in your code. But as long as your rule is only the only mailer exists inside the email service as a private variable, you're far safer. And then you want another requirement, and this is often where problems get introduced. Requirements change over time. You know, your business that was sending one email to one person at a time actually goes, oh, we want to send this block of emails to these people so they all know they've got it and they can reply to each other or some funky thing. So you'd be tempted to go, all right, let's just change all this. Let's change this to an array, and let's just hope the existing implementations just still work at the end. Don't do that. When you're making changes to systems, one of the solid principles suggests you should add new things or extend existing classes rather than modifying your existing methods. Add a new method here and do its own things. Here we're even clearing the array at the end as an extra little safety net against anything else consuming this and putting it into here with this array in it. So the best code is generally obvious. Okay? Obvious code. Obvious code will save your life. Obvious code will save you from emailing 1,000 times to one person with a progressively larger email list. It was a fun one, I must say. We look back and laugh through tears. What else did I do? Hid errors where nobody could find them. I bet you've all done this. All these people smirking at me at the GitHub password thing. No, this is one where you all fall down, I think. I don't have a single example of this because I think I've done it too many times until I realized it was a bad thing. So if something's not working, right, you get a report, bug report from a customer or from a staff member. It's fine. We've got logs. It's probably just gone wrong for the first time today. Let's check the logs. Oh, that's a lot of log files. How long have they been building up for? Days? Weeks? Years? What went wrong? Well, here's a common paradigm. You have a function doing an important task. And then it says, do the thing, and if it goes wrong, okay, catch all exception, right? We don't know what could happen. Maybe it's using a third-party library. We don't know what kind of exceptions are going to get thrown in there. Catch any PHP level exception. These days, you could even be catching any throwable, like PHP fatals and things, and doing really wacky stuff with your logs. And then just log it, right? Log it, move on. Or maybe you log it and return early or return false or something. But you log it and you get on with the task at hand. Because you say, I'll just deal with this later. Has anyone seen Arrested Development? He didn't. And now we have a lot of logs. This is a specific example if you're running on Docker, by the way. So we need a better way to manage our logs, right? We've got all these log files building up and aggregating over time. So again, let's fix that. Let's find a way to manage our logs better. Log everything to a single source. This might initially seem quite weird. You've got all these services doing different things in your application. Here's the service that's logging users in. Here's the service that's publishing blog comments. Here's the service that's handling payments. They all have a log right now, probably. You know, auth log, comment log. Weird error we didn't understand, but the guy left log. But logging everything to a single place gives you a really good source of truth as to exactly what your application is doing. The popular PHP library Monolog, if you haven't heard of or using Monolog, go and look up and use Monolog. Does this. It's a convention of it. It's going to say log everything to one place and then handle it afterwards. And the great thing about logging everything to one place is you know where everything is when something finally does go wrong. But then let's go further. Send your logs to a log management service. Because just looking through a file in a text editor or using less or some weird, there's always someone on the team who knows some weird things in sed or exargs or Perl to get file, log lines out of a file. Don't do that. Put it in a service that lets you look at your logs easily. And there's a few pretty common ones. Fairly common is the Elk stack. The company behind the Elk stack are trying to rebrand it the Elastic stack, but I prefer Elk because it sounds like an elk. And although it shouldn't really be Elk, it should be Lek, because it starts with Logstash. Logstash takes files from a system. You can create cool pipelines to send those logs somewhere. That somewhere is generally Elasticsearch which if you haven't used it is a really fun full text search database with like a JSON API. And then Kibana graphs and visualizes all that log data for you. So now all these log files can actually do something useful. And if you're not using Monolog, Logstash can handle log files in multiple places. Using something like Monolog just means you're less likely to lose one set of logs down some really long directory tree that some developer wrote one time, and you find they're just building up and up and up. Logs can also fill up a server hard drive, right? So like seriously be careful about just logging everything all the time. I didn't put it in this talk, but we did have one time where a server went down because its hard drive was full of logs. And then there's also managed services, so AWS CloudWatch. I do a separate talk about CloudWatch, which includes a screenshot of the CloudWatch pricing page, which fills the entirety of a slide and you can't read it. So CloudWatch is a bit weird with their pricing, but it's a really decent service. If you're already on AWS, you'll already be consuming some of your logs from AWS services in CloudWatch. So logging your own stuff to CloudWatch makes quite a lot of sense. They have an agent you can run on your web servers that just filters the log file off to CloudWatch. So I recommend that if you're already on AWS. Or look at Datadog. Datadog have a log tool, which is relatively new, a few years old, which is basically a managed Elk stack. It's pretty much just running Kibana. If you have used Kibana and you use Datadog, you'll be like, this looks suspiciously similar. They're just running their own Elk stack for you. So if you've used any of the stuff with the Elk stack, Datadog's easy. The reason I like Datadog for this is because I think that managing your own logging and error reporting infrastructure is a red flag to me. Because who's managing the logging and error reporting infrastructure for your logging and error reporting infrastructure? And how far down does that rabbit hole go? I don't really want to be responsible for managing the thing that tells me my thing's broken. So, you know, you might love that, but it's not really for me. But also consider is logging what you need, right? You started adding these logs, maybe because it was convenient, maybe because that was just the way it was done. But is that actually helpful to you? I define these in terms of visibility and awareness. This isn't some technical term, these are some words that I've made up and assigned to things. Visibility gives you insights into how something's working. Okay? So it's a deep dive, it's like getting a trace of your code. It's information about every part of your stack, it's Xdebug, it's various other things in terms of how your service is operating. And it's very detailed, right? It will tell you everything you need to know, but it requires knowledge of the system to understand. And that might not just be being a developer. That might be being the developer who wrote this thing. Right? How often in a log file do you just see the line like done? Done what? What have we just done? Have we done a good thing? Have we done a bad thing? What does done mean? So, you know, the developer wrote it, knows what done means. He knows that he's done for. And they're generally verbose, there's lots of information, so they have to have management tools. Whereas awareness is just insights into whether a service is operating, maybe whether it's operating in the right way. And there's minimal detail. One of the things I love about things that give you awareness is it's obvious to anyone. We're going to talk in a moment about dashboards, but if you have a dashboard screen up in your office, lots of people do because they look cool with all these lines on. The cool thing about a dashboard screen that's done well is it should have a line on it partway through that says, if the line is above this, call someone. That way, even if the person who cleans your office is the only person in when your CPU load spikes, they can be like, I should call that person. So anyone in the team suddenly becomes a valuable member of your debugging stack. Okay? So they're obvious to anyone. And it's hard to miss problems when you have awareness over your system. The only problem is it's hard to work out why. So generally, to fix problems, you may need some level of logging and debugging ability. But awareness, I think, is far more crucial for most general day-to-day business operations, because hopefully, most of the time, stuff is working. If most of the time for you, stuff just isn't working, maybe just a lot of these lessons are like way too high for you and you need to start lower. But hopefully, it's the case that you need to spot that one time when it isn't working, and that's suddenly crucial for you. Ways of getting awareness, metrics, simple counts or sums, averages, that tell you what something is doing. How many users have signed up in the last hour? If your site is used to getting 100 users sign up an hour and you get none, is your user flow broken, even if there's no error logs? Probably. If you are used to getting one payment in an hour and you've just processed 10,000, either, well done, your business is booming, or something's gone wrong somewhere and you're going to owe a lot of refunds. So they're easy to collect and distribute. So service I've already mentioned, Datadog, AWS CloudWatch, they have built-in metric filters. The Elk stack can do metrics for you as well. Metrics are great. Metrics you can graph on dashboards. You can put alarms on certain values of them. Is it over a value, under a value, going really weird? Right? Metrics are great. The other thing is notifications. We started doing this about a year ago. Any PHP level error goes straight into Slack, into the main channel in which all our developers chat. They initially wanted it to go into a separate channel, but I knew they'd all mute it. So it goes right into the developer chat, any PHP level error. So someone sticks some code online that has a type error, straight into chat. Someone sticks some code online that does a PHP fatal, memory runs out, anything else, straight into chat. Now, I must clarify, because I mentioned this to someone at a conference a few months ago, and they decided that this was kind of a weird form of us shaming our developers. Like, who did this? You're fired if you don't fix it in 10 minutes' time. This isn't about shaming your developers. Please don't, if you're managing people, please don't go and just shame all your developers by putting your error logs into chat and labeling it with their name. This is about the whole team having a responsibility to make sure the product is working. Now, it might mean that there is one developer responsible for that area of the site, and they do have to go and fix it. But this is about gaining awareness and learning together as a team, like we're doing here. So please don't take this and go off and do this terrible management practice and upset everyone on your team because of it, because I don't want to have that on my conscience. And you can turn logs into metrics. So services like CloudWatch let you take a log line, turn it into a metric, and then you can send an email into your Slack channel and you have everything all at once. This is good. Helpfully, this kind of thing lets you spot other issues, which we didn't spot at the time when I deployed half a feature branch to production. Yeah, better tooling can really do you well. We got an error. Someone said, oh, we've got this problem with the site, and we obviously, normal thing, okay, open the code up, look at it, doesn't make sense. It was an untraceable bug. Users were experiencing truly obscure errors, right? You've had these as well. You've had a time when you've been working on something, and you are convinced that the laws of physics and mathematics working inside your computer must have changed somehow, because this code is right. It's like reading 1 + 1 in your code, but the answer's coming out as 3. I mean, that can happen because of weird floating point issues, can't it? But it's like that. You are so convinced, you're like banging your head, maybe physically on the desk. I think I have a few dints. I was debugging this on a train, which made it even more fun. Pages were loading data that shouldn't even have existed in the first place. So it wasn't just like, oh, this loaded the wrong data. It was like, this data shouldn't be there, and they were loading it. Where's this data coming from? And they were saving data to find that it was just changing to different data, different arbitrary values. You know what the worst part was? It all worked on my machine. Downloaded a copy of the live database and ran everything the user said they did and everything the logs said they did, and worked perfectly. Everything exactly as had been expected. Let's look at how we were deploying our code at that point. Firstly, we check out the right branch, mainly master. Then we run multiple commands to build. So this involves basically a list of commands that I knew in my head, running one at a time in the right order to build different bits of our stack. And then deploying with everyone's favorite tool, FileZilla. FTP. Now, I am hoping that this is the one bit of my talk where everyone is just like, well, we're past this. Why are you even talking about this mistake? But maybe someone out there is using FileZilla. Maybe someone's still deploying using FTP. Maybe the reason they're not telling you they're using FTP is because they're almost embarrassed. But I think embarrassed that you're doing the wrong thing isn't reason not to talk about it and make sure you get it fixed with the right thing. Okay? Don't just hide behind it. And so you follow these procedures, but still, it worked, right? It worked most of the time. All the time until this point. Drag the files across. If you thought you'd made only a few file changes, you obviously save time by just dragging a few files across, right? And this is where the problem lay, because I kind of missed doing the first bit. So I'd copied the few files I thought had changed in master from a feature branch. Weirdly, if I deployed the entire feature branch, we'd have just had to be like, hey, users, this new feature's live. We hope we've tested it. But it turned out, actually, we deployed files from feature branch that didn't interact well with the rest of the system. And so we had a really failing system. Now, as I say, maybe we're past deploying with FTP. Maybe we have other systems. But as developers, do we really know how we're deploying things? We focus a lot on gathering requirements. Okay? And then are we doing sprints? Are we doing TDD, pairing, mob programming? Are we doing Kanban? You know, we have all these cool things and words in Agile that we use. You know, we have our waterfall-based Kanban boards and things like that. And then we do testing. We do acceptance testing, functional testing, unit testing, all the testings. We're using Browser Stack to do testing on IE6 because we have some masochists still using our system. And quality assurance. Maybe you're lucky enough to have a QA department who's just testing your stuff for you. Maybe you do focus groups where you go out and buy people pizza to test your application that they can click a button. But then we get to deploys, and we're sort of like, I go to the cloud somehow. Yeah, we need to know our deployment systems. So firstly, make sure your deployment tool is version control aware. In this case, a simple git checkout master would have saved us all our problems. But also, deployment should be a one-action process for the user who's saying this code now gets deployed. Adding a long list of commands in is definitely something that can happen as your system evolves, because you go, oh, we're going to move from compiling this thing to also splitting this out, and we're minifying some things, and we're doing some tests, and we're building some containers, and things naturally just kind of ebb into 5 steps and more. Or maybe you say that you're fixing that by putting them all in a bash script, but do you really know in a bash script that if one bit fails, the next bit won't just continue anyway? We need good deployment systems. We want a deployment system to feel like this. Press the button, automated, perfect, right? I don't know if anyone watched the live stream of this, but this bit felt freaking brilliant, didn't it? You know, the rockets landing simultaneously. It was like a sort of space ballet. So we've got some solutions to this. These are some solutions to this. Gulp, grunts, they are popular JavaScript-based build tools. Apache Ant is a bit of an older system, but Ant was established for many years, especially in the Java world, as a build tool. Uses XML files. There's a sort of PHP derivative of this called Fing, which was my first foray into build tools after this incident. And then you've got continuous integration servers. Now, people are probably using their continuous integration mainly to test things. You know, new branch gets pushed, run all your tests. But obviously, you probably know that your continuous integration servers can do things like deploy for you as well. But obviously, you need a pretty trusted deployment process to trust your CI server with deploying stuff for you. So let's look at that actual bit. So let's look at actually deploying. How do you get code from one machine to another one in a way that doesn't break things? I'm going to look at 2 sort of paradigms of deployment. Atomic deployments. This is where you have a few steps. You can all see that? Good. You upload all your deployment files, your entire application, or the entire service if you're using microservices, to a timestamped file on your server. You then sync that between multiple servers. So if you've got a few servers running at the same time, you might want to use something like a distributed lock file to make sure they all deploy code at the same time. And then you switch a symlink. So you have your web server config pointing to some symlink, and that symlink just goes from old timestamp to new timestamp. And your new application is running. Now, a challenge for this, if you're moving from a system where you basically just deployed files in place from my directory to web server directory, is that your code might depend on other files, like user-generated content, in the same directories. Now, if you have this is a very common thing, especially for systems like WordPress. By default, a lot of CMS systems store their content within the directory all your code is in. And therefore, if you use those systems and then built your own applications, they might look like that. You're going to have to change that bit. But it's worth changing that bit for other reasons anyway. I'll talk about that in a bit. So there's a challenge there. The other deployment paradigm that's becoming more common now is BlueGreen Deployment. I was going to talk about that. I totally missed it. I'll move out the way. This here is a system, if you're not using atomic deployments and you have no idea where to start, and you're on, and you like S3, use this service. It's a Python library. You run it on your server and on your local, and it allows you to push files to S3 that get deployed automatically onto web servers with about 1 second latency between servers. So this is what my current company is using in production. So yeah, if you're interested in something like that, I'm sure I've reinvented the wheel, but I quite liked it, and it gave me a chance to write some Python. BlueGreen deployments are another good strategy if you're hosted on an autoscaling system. So if you are on AWS with their autoscaling, or the Azure, or for the one person who's using Google Cloud, you can use autoscaling to bring up new servers from images. Or if you're on containers. Now, if you're on containers, you're almost probably using this by default, because this is how most containerized systems deploy. But basically, you build your code into an image. So on Amazon, that's called an AMI. Various other services will have their own systems. Using Amazon, AWS, sorry, you would want to use something like Packer to do that build for you, which is a tool by HashiCorp, same people who made Vault that I mentioned earlier. And then you deploy your new images or your new containers alongside your existing ones. So your existing ones are there, running your website, you bring your new ones up, and then you have something like a load balancer that says direct traffic to these instead of this. And once all the traffic is going to the new servers, your old ones get destroyed, dismantled, whatever you want to call it. Again, that has its own disadvantages. You will now need some sort of central storage for all your files because you can't rely on a server staying there for you. But again, this strategy goes far beyond deploying your code. This strategy is really good for deploying infrastructure. Upgrading that PHP version that you've stubbornly kept on 5.6, even though it's out of support and PHP 7 is so much better. Using stuff like BlueGreen lets you get past those hurdles. So even if you're not deploying your code this way, do that for your application infrastructure and get with the times. But overall, choose what's good for you with the deployment, and just remember to do it the right way. Finally, I deleted 100,000 user-uploaded photos. I genuinely, when I'm typing this slide, I kind of got that heart feeling that I got when I originally realized this had happened again. It was like the kind of inverse of an adrenaline rush. It was like, felt like the world was sort of compressing around me slightly. This is definitely the most painful mistake I've made. I'm being reminded about it by numerous people over a long period of time, and now I've told all of you. What went wrong? Part 1. One of our earlier ways to get off FTP was Rsync. Rsync's a really nice tool, really nice shell tool. You can copy files from one machine to another or from your machine to a remote via a delta copy. So it only copies bits of your files that have changed. So you've got 300 megabytes maybe of application because you've got an enormous vendor folder because you're using some libraries that use one function of one time in one script and you deploy it every time. Rsync gets rid of all that by simply copying what's changed. It checks the deltas of your files on a server and deltas of your files locally and copies them. Rsync is a pretty good way to deploy things if you're deploying in place or even if you're deploying to atomic deployment, something like that. It's got lots of features. It's great for backing up files as well. And it runs SSH by default. So if you're on FTP, at the very least, do yourself a favor, move to using Rsync. Now, I wanted to move to Gulp because I wanted this whole pipeline build system, the one press, amazing rocket landing wonder. And luckily, Gulp had an Rsync library. So you can see there, I've basically transposed my Rsync command into the Gulp Rsync command. Now, this command was literally lifted straight off the Readme. Okay, get the Readme. This is what we do a lot of the time, isn't it? Get the Readme, get the block code that does what we want to do, put it in our project, change the variables to what we want, run it. And we were sort of expecting our awesome deploy process to go like this. Then we get a message, hey, photos aren't loading on the site. And I check, and I realize that we've kind of done more like this. Every single piece of user uploaded content was gone. All our logs are gone. All our cache files are gone. Everything. We have some frantic moments where we try and shut the server down, use an undelete program to recover the fragments of files from the file system. This worked apart from the fact that it lost all the file names, without which it was pointless because we had 100,000 of them and they were linked to user-generated content named with the file IDs. So, undeleted pile of crap, basically. What really went wrong? This is an extra command that you won't generally want to type into Rsync. -- delete all. We talked earlier about naming things, didn't we? -- delete removes all files on your remote that aren't on local. So it's if you want to deploy to your remote and get rid of all those nasty temp files and log files that you don't want hanging around, your remote becomes an exact copy of your local, including getting rid of any files that are there. Adding the all also ignores any files that you've chosen to exclude on your side of the transaction. So delete all is pretty damaging if you've got files there you don't want deleted, but it's very well named. I told you I copied some code off the Readme. This was the code on the Readme. All the normal stuff, SSH, dest, And then this one, sync dest. That's a nice term, isn't it? Sync dest. This was the subtle way of the plugin author calling delete all via a somewhat ambiguous rename. Here's the readme now. Even includes, careful, this could result in data loss. That was the most I've had to try to be polite on a pull request ever. So I submitted that change. While saying, by the way, this has just cost me 100,000 photos. You're probably asking the obvious question. So was everyone else on the team. So we were backing up the database nightly. And that's because a friend had put a bash script on his GitHub to show you how to do that. And I thought, that's a good idea. Back up the database every night. Let's start doing that. But all those files, though, it was hard to make the script change. It was bash. I didn't understand the direction. Yeah, I hope it's obvious that you need backups. And I don't really care what stage your business, project, anything else is at. You need backups. The little hobby project you're working on today that 2 people somewhere are using, in a month's time, 2 months' time, 6 months, a year, could be a major business. All running on the same infrastructure, same setup that you're running on now. Do you think in that time of accidental stratospheric growth of your startup, you will have decided to go back and program backups in? After the first delete, you program backups in very fast, yes. You need backups, you need them now. Genuinely, if you're making anything other than like hello world, put something in to back your stuff up, because you never know where your projects are going to go, and this is so common. I mean, it's common for loads of other things like tests and security and stuff, but like, try and build those things in. Today's prototypes are tomorrow's headline news. You won't know until you need them, so back up your stuff. But more than that, don't just back up your stuff, check it works. Backups have that insidious thing, that one piece of your stack you never think to check, because you never need them. Web server goes down, you know instantly, hopefully. Database server goes down, you definitely know instantly. You get hacked, you probably know relatively quickly, I guess. Backups don't work. Years. Years of your backups not working. If anyone heard about the big database delete issue that happened to GitLab a few years ago, they realized that 5 different backup systems had all been failing consistently for years. 5 systems had all been failing consistently for years. They fortunately had the ability through their binary log on their database server to roll back to a point, I think it was 6 hours beforehand. But a company of GitLab scale, 6 hours is a lot of customer data lost. Check your backup processes are running somehow. I don't really care how. Send yourself a message or an email or pipe it into your Slack channel. Or have something that checks and raises an alert if it doesn't run. And check the files are correct. We initially started saying, how's the backup run? One day we realized it had been backing up the same old database file repeatedly. All right? So now we have a backup process that literally unzips the database, loads it onto a new server, and emails us the latest record daily. So we can see that, yes, this is still working. And then our analytics team needed a way to like get data into another service, and we thought, brilliant, we combine it with our backup process. So now our analytics team are the first people to tell us our backups aren't working, which is fantastic, right? That's a way of using a business goal to meet your much more important development goal. Make sure your backups are there when you need them. And keep checking forever, okay? Don't assume you're done with this one. In conclusion, why have I stood up in front of all of you and bared my soul and had people laughing at me, about what we're doing? Well, I'm talking about this because I want to encourage people to share this. I want people to learn of what I'm saying, but I want that to go further. I need to share the mistakes you're making, right? That time you commit something that breaks something and you fix it subtly and no one on your team notices, cool, you fixed it, go share it afterwards, right? Let people learn from it. Don't hide these things away, because then someone else on your team will make that, and then someone else, and eventually that will get noticed and that will cause a big problem. And that person might get fired, and you could have stopped them. So share those things. And I think as developers, we often end up going in at the deep end. That startup that becomes a full-time project. We need to make sure that we are building in good practices and the ability to share and guide each other from the start. Find safe spaces, things like this, places to talk about problems. do hobby projects that let you make mistakes in a safer environment. And go out there and make mistakes and learn from them. Thank you very much. I understand that I think I am over the time for questions. Am I not? Oh, good. That's fine. I overran, but that's cool. We have time for questions.
Okay.
Oh, we have roaming microphones as well. This is a great setup.
Hey, how many times have you had the heart attack moment where you realise you've dropped the prod database?
I have never dropped a prod database. A little while back, I was messing with some settings on our load balancer to try and thwart some weird requests that we were getting from some Chinese IPs. And I made one tweak too much, and the entire live site went down in the middle of the working day. We power PropTech systems that large agencies use to manage their services. We hear about that within seconds from people because their websites rely on our system as well. So that was a heart attack moment. And the worst part of that was, to fix it, we had to wait for DNS propagation. Never have you been so happy at short time to live values on DNS caches as you have when you accidentally screw up your load balancer in the middle of a day. So yeah, but I never dropped a prod database. My admin user on AWS has specific deny rules to prevent me deleting the database, even if I try to delete the database. And I recommend anyone on AWS to do that. Put big roadblocks in your way to doing stupid stuff. That's maybe one I could have said, but that's kind of, that's a theme throughout the entirety of this presentation. Stop yourself doing these stupid things first.
Any more questions? I must have a question.
Not a question, more like great talk, by the way, but I just wanted to add one thing to the last bit about the backups, because I have seen this happen. Don't put the backups on the same server, because I have seen this happen, and it was a disaster.
Yeah. I mean, the challenge of doing that, we used to back up to the same server. The challenge of moving those to somewhere sensible was what made us first exploit AWS. So like, if you're not on AWS, you don't need to migrate to AWS. It's great. I'm a big AWS fanboy. But S3, their storage service, is fantastic for backups. It's got every feature you could think of to make it a great backup service. We store daily backups of our database going back a long time, and it's still costing us almost nothing to do so. So yeah, if you're not using AWS, just shove all your backups in that to start with, and then work out what you're doing afterwards. But yeah, it's a great service. Anyone else?
Any more questions?
Oh, we got one on the front here. We're just giving Craig some exercise, basically. We've got to have one at the back next, right?
Great talk. Thanks, Mike.
Thank you.
A really kind of generic question. Do you think things are getting better or worse? I.e., is it getting easier to make mistakes or harder to make mistakes as processes maybe help?
I imagine it's staying roughly similar. I think we are getting, as a field, software engineering is maturing. I think there is, things like the evolution of the PHP language, for example, can be seen as a real key thing to this. PHP used to be laughed at by a lot of people as having tons of insecurities and failure cases, whereas you now have a relatively robust performant and possibly statically typed language that you can work in. So, software gets better and advanced over time. What I think is a problem is the lure of the new hotness. This is especially visible with things like containerized environments, microservices. Some people point out that if you have an application that has a user section and a payment section, and your controller calls your user and then your payment, that's 2 function calls. Now those services are separate containers running somewhere, and it's 2 network calls. Now the random failure rate of just a function call in a language is insanely low. You rarely expect to call a function in PHP and have the function just go, no. Right? It works, right? It works every time. Network failure rate's a bit higher. Big traffic application, your network failure rate is going to be maybe 1 in 10,000 requests might just not come back from your network. And so you have people adding these new systems to prevent old problems and coming up with a whole new set of them. And I think that people rushing into that stuff without knowing it, again, make your mistakes somewhere else first. You know, don't bring this new JavaScript library's come out yesterday, put it into prod. Like that's become weirdly common. You know, you've got conferences happening for frameworks that have been out for 6 months because everyone loves the new thing. So I would say just, you know, a big dollop of caution. It might seem boring and old school and stuff, but make the mistake somewhere else first. Use the new stuff just for non-critical things or hobby projects or internal projects. You know, admin databases and dashboards and stuff like that. They're great for that because if it fails, it's only your internal team that it affects. So yeah, I would say that's my thing. I don't think things are really getting harder or easier. They're just getting different.